So let's look at Beth's error. This is a little small. So 3P3, what does the P stand for? Permutation or permute, yeah. So order matters. And then 5 choose 3 or 5 permute 3. Okay, so she did 3 factorial over 5 factorial over 5 minus 3 factorial. Basically, this is applying the formula. How many of you have been looking at these after we talked yesterday? Just your notes in general. Okay? So, it's using this formula for permutations, n factorial over n minus r factorial, where n is the total choices and r is how many you pick. So 3 factorial over 5 minus, or 5 factorial over 5 minus 3. Any issues with that step? So if we're picking all 3, here's our formula. So 3, so n minus r factorial. Well, 3 minus 3 is 0. What did we say was the definition of that? It had to be 1, right? Because if we called it 0, then this would be undefined. So no issues there. Okay, and then 3 factorial over 512 factorial, which is enormous, right? If we punch that in, our calculator would probably struggle. I wonder if it would even do it, honestly. It won't?
It wouldn't even do 110.
Factorial? Okay. Yeah, I figured these.
It's 5 factorial times 2 factorial.
Oh, is that what that says?
Yeah.
Oh, I see it. That's not a 1. Okay. And then 1 over 40. So where did they go wrong? Or where did Beth go wrong? Right here?
Yeah, the factorial.
What should that be? Yeah. If we wrote it as fractions, I guess the bigger line would be here, like that, which really means bring this 2 up here with the 3. So it should be 3 factorial, 2 factorial over 5 factorial. Okay, so just, it's actually a fraction issue, not a probability issue. Alright, next one. Find the number of. So how many ways can 12 runners in a race finish first, second, and third? What's your first question? Does order matter? And so does order matter in this?
Yes.
Yep. So this, because you definitely want to, you want to know which one of these you are, so order matters. So this is a permutation. And so filling this out, what is n, what is r?
Is 12 R.
Good. Okay. Is that going to be more or less than if we had done combinations on this? Oh yeah, I always forget that. Yeah, this calculator version. Anyway, 12. Choose 3. So 1320. That's kind of wild, huh? 12 people, 1,320 different ways you could arrange them. How many ways can 11 contestants for an award be narrowed down to 3 finalists? Is that order matter or order not matter? That's a not matter. So this is combinations. And then it's just, so 11C, 3. And what'd you guys get? I'll just write it.
165.
Okay, a little bit of kind of basic combinatoric problem, or probability. 6 athletes and 8 non-athletes, trying to get 2 possible prizes. What's the probability that both prizes are awarded to athletes? So, this is, because it's probability now, we've got to do the number of interest over total number. How do we find the total? Remember I said to start with the total number of ways? So what's the idea here? Yeah, brother?
The total amount of people that can get it, so it'd be 14.
Well, that's the total number of students that are eligible to get an award, but we're talking about, let's describe it.
So it'd be 6.
No. Because what are we actually doing? Out of those 14 people, because you're right, it is out of the 14, what are we picking?
2.
So we're only picking 2. So the total ways to pick 2 people is our denominator, right? Okay? So I shorthanded this a lot, but let's be super clear on what we're actually calculating. And maybe that will help. So the probability of one of these is the number of ways or choices that we're interested in. In this case, how many ways can we award 2 awards to non-athletes? Okay? And then number of total choices or ways. What'd you say?
We're doing the one above that one. They're both prizes or
Okay. Yeah, I read it wrong. Okay, and yesterday I emphasized these words. Okay? So it's not just total people or total available options, it's total ways that we can pick, right? Total ways we can pick. So for this, we're giving only 2 awards to 2 people out of 14. So how would you describe the denominator again?
How many ways we can give the 2
Yeah.
awards?
How many ways can you pick 2 people?
Under
Out of how many?
14.
Is everybody clear on that? How many ways can you give an award to 2 people out of 14? Okay? So that's going to be what?
Under
Well, but how do we write it before we get a number? Is it
14.
C or P?
Let's see.
Okay, so if they both get the same award, it doesn't matter what orders.
14.
What goes here? 14, choose 2 of them. Okay, numerator. How many ways can we award prizes to athletes? 2 prizes to only the athletes.
6.
Yeah, so we move this out of the way. It says 6 athletes. Okay? So maybe I'll put that up there. So 6 athletes, choose 2 of them. Everybody good on where those came from? Okay? And then we just punch in the numbers. So, and you can set this up as a fraction if you want in your calculator without having to do it twice, I mean. So 6 choose 2 athletes, and probably a good idea to put parentheses around that. And then divided by 14. Choose 2, and we get 0.165. So we have 16.5% chance of that. Okay, let's just talk about setup. Both prizes awarded to non-athletes. How would that setup change? Any?
Instead on the top, instead of going for 6, choose 2, we do 8, choose 2.
Yep. So we would just switch over to the non-athletes and do 8 choose 2. Okay, no prizes awarded to an athlete. What's another way of saying that?
2.
So isn't that the same as 12?
Oh, no, it's 13.
Sorry, 13. And then 15 is the same as 12. Okay. How's this going for you? Okay. Yesterday I told you that we weren't quite to the hardest stuff. Well, we got there yesterday, and this is kind of a continuation of that, and we're going to continue it today. And then after this, I think you'll find things get a little easier towards the end. Okay? So if you're tracking with combinatorics, I think you're in a good place. If you're still needing a little bit of clarity, make sure you're asking questions, make sure you're doing your practice, and that kind of stuff. So, let's see. Let's hand this out, I think. So try one, we'll talk about it, and then maybe work on a few more. Alright, so first thing to note, actually, well, I guess this could be the first thing. There's two that are really important things to note. This says probability, so we know that we have to have it be, I want to try to shorten this but still have it be informative. Ways of interest and out of the total ways. So we have to have it be a fraction, something out of something. Okay, second thing is, as soon as you start reading things like 11 raffle tickets are sold, 2 will be selected. What kind of synonyms did we write down in our notes yesterday? For that word, for selected. Pick, grab, choose, options, right? So that word is telling us, let's do pick. So this is telling us it's either C or P. Okay. And again, I want to keep pushing you to clarify, because we've done a lot of different probability scenarios, and it's not going to say this is a permutation problem, or this is a combination, or this is conditional probability. So let's start working on those keywords to figure it out. So probability means we have to have some kind of a fraction, and this word selected is saying, hey, this is combinatorics. So first thing that you ask once you realize that it's combinatorics is what?
Does order matter?
Yeah, does order matter? So does order matter? No, because it doesn't say first and second, it just says that both win, okay? So whatever they win must be equivalent. So I said yesterday, start with total ways, and if you're following these notes, so we said either permutations or combinations. We just decided it was combinations. And then we have this basic formula written down. If it asks for exactly, we'll talk more about this today, account for both the is and is not. That is not this case. Also, we're going to do that, we'll have an option to do that a slightly different way if we get there today. Okay. And we need to write an example of steps in there. So start with the total. So let's describe it first. Sorry, and then I think you said it right. What is the description of the total ways? How many ways we can what?
Pick 2 winners out of 11.
Pick 2 from 11, right? And we already said it's combinations. So Nate, you said, I think you said 11, choose 2, right? How many ways can we pick 2 from 11 without order mattering? So there's our denominator. And then how do we do the numerator part?
I did 2C2 because you want to pick 2.
Okay. So here's what he said, 2C2. What do you guys think? Huh?
No.
Well, it says, what's the probability that both Beth and Shayna win? So those are the only 2 that we care about, right? So this is not a 2 out of, well, it is, but it's 2 out of 2. So he's right. It's 2 to pick from. How many ways can we pick those 2 if order doesn't matter, which should be what?
One.
Just 1, yeah. Okay, So this is 1 out of whatever this number is. Okay, 1 out of 55. Good. Huh? What percent? Like 0.01 something? Like, well, 1 point something percent? Okay. Alright, try number 2. Alright, so we have 14 government officials, but 4 of them are spies. So the diplomat is giving secret information to 10 of those. So again, let's think through the analysis of our approach. What is the probability? Tells us that we're going to have to use the probability setup, the basic equation. And then it says that no secret information was given to the spies. If the diplomat gives secret information to 10 of the, so that's like pick 10, right? If we read into it, if we read the between the lines, pick 10. So this is combinatorics, and I know it says that right here, but start really developing how you know that it is without being told. So, probability, no information to the spies, so I'll just call it probability of no spies. And we know we need to do the total ways. You guys, I'm telling you that you should do the total ways first, not that you have to do it that way. It just helps frame what you're looking for when you do that, when you start there. So, describe the totals. Like, what are we counting as a total? Ryan, how about you? How do we describe the total?
The total being the 14 government officials that the 10 are heads out of.
Yeah.
So it'll be 14 choose 10.
Good. Does order matter?
No.
Okay, so we're choosing. How many ways can we choose 10 of these officials out of 14 total? Okay? All right, once you start putting a name to that or a description, then it helps you with the numerator. So, describing the numerator, how many ways blank? What would you say? Or hey, how about you?
Well, I said, well, out of the 10 officials, I'll pick 10.
Okay, tell me why. So you said this.
Let's see.
Yeah, good. But why did you say 10 choose 10? I'm not saying you're wrong, I just was curious like what your thought process was.
So, there's 4 spies, so we take those out, and then we can only tell the 10 officials.
Good. And we have to pick 10 people, so we're going to have to hit it right on the nose of picking just them, right? Okay. Well, how many ways can you pick 10 out of 10? Order doesn't matter. Just one. And then, how about this one?
Okay.
Denominator, what value was that?
1,000.
That's very unlikely.
Yeah. So he's going to spill the beans to somebody. Most likely. Good. All right, read number 3. A fair coin is flipped 10 times. What is the probability of the coin landing heads up exactly 6 times? So don't start working on this one yet. Just I want you to think about it. This is a different question than the other two, right? Like it's different setup, different thought process. Yeah.
For the denominator, which is 10 times 2 choose 1. Because there are 2 options on the fair coin, and then you flip it 10 times.
Okay. 10 of those.
Because you flip it 10 times.
I don't think that works. It's a good thought, though. I think I know where you're going with it. Okay. I will tell you that these kind are easier to think of flipping, or the next one is rolling. to do it all at once. Instead of doing it repeatedly, just take 10 coins and flip them in the air. Okay? So there's 10. If we just flip them all at once, that's kind of the idea. It's exactly the same idea as flipping one coin 10 times. Okay? But I think the reason it's easier to think of it this way is instead of saying, okay, I'm flipping and counting how many times, just say exactly 6 of these have to have heads up. Okay? Does that make sense? Why it's a little easier to think of? It frames it a little bit more like this. Like, how many ways can 6 coins land heads up kind of idea. Okay. So this one and number 4 are kind of different. I think number 5 is way different. So we are going to generate a new way. Like I said, hopefully today we'll get to it, but I do want to do a few more of these. Called binomial probability. That will make this a little easier. But I do want us to understand how this looks using combinatorics as well. So, any thoughts on how to set this one up? In the same way that we have been, or a similar way, I should say.
For the total, you think, you know how it's like in choose R, for like
And CR.
NCR, yeah.
Okay.
I'm thinking for the end, maybe like 20 on the bottom part,
Okay.
because you can advance 10 times and tails 10 times.
So you feel like there are 20 possible options. Okay.
Yeah.
Choose what?
Choose 10 of those because you're looking for heads, right? Heads.
Yeah, so heads up, but okay. So good thought.
Yeah.
I see where I think I get it. So he's saying there's 20 options. Thinking of the denominator, there's 20 total ways. Like all 10 coins could be either tails or heads, so 20. Okay. And then you said choose 10 from 20. So 20 C 10.
Yeah.
Okay.
It's about that, but yeah.
Any other thoughts? How many ways can 10 coins be flipped? That's the idea.
Okay. Not right now because there's 2.
How many ways can one coin be flipped? 2. Heads or tails. And then, okay, so she says 10. Wait, you said 10. 10 choose 2. I had to do 2. He said 20 C10. Will you do that? 20 C10. Or unless you're doing something different than what he said. Which is also okay. 20 C10 is 184,000. All right, let's pause here and have a break. All right. So this is, at least in my opinion, this is where probability gets frustrating. It's when you kind of say like, hey, I've got the hang of this, and then it twists it on you. So, like I said, we're going to learn a tool that will be more helpful with this, but you can do it with combinatorics. It's just kind of weird. So we still do the same idea of total, or number of ways of interest out of total ways. So in this case, total ways to flip a coin. A coin 10 times. This is not a C or a P. It's just how many ways can I flip one coin? 2. And I'm doing that 10 times. So it's just 2 to the 10th. Okay? And the reason why is because I'm not, in that case, I'm not choosing anything. I'm just doing a process over and over again 10 times. Does that make sense? We're not picking a certain number from a certain other number. It's just, let's do this 10 times. So there's 2 to the 10th ways to flip a coin. Just like there was back, I guess, last week, when if I said, what's the probability of flipping tails, tails, heads, heads, tails, tails. Right? It's 2 to the whatever I said, 2 to the 7th. Okay? Anyway, the numerator, in terms of ways of interest, that does have choices now, right? Because we're saying choose heads 6 times, is really what we're saying. So, choose heads. I'm putting choose in quotes because we're not actually picking them, but that's the idea. Choose heads 6 out of 10. Well, how do we decide that? Does it matter what order it is?
No.
So if you think of these 10 coins, if we just toss them in the air and look at them on the ground, who cares what order they are? So this is a C, right? And then we have 10 quarters that we're looking at, and we want 6 of them to be heads. So if you think about maybe them landing on a grid, maybe it's the left 3, the middle 3, whatever. Maybe it's the top 3 and the bottom 3 or something. Okay? So what is 10C6?
210.
And 2 to the 10?
1,000.
Okay. And then we could reduce this, they both at least divide by 2. So 105 over 512. Okay.
Just over 20%.
Yeah. Yeah, because it's roughly a fifth, so just over 20%. All right, try a similar strategy, but now we're rolling dice, so try a similar strategy with part, or number 4. And just before you do that, do you feel like this is helping
Yes.
with all these different twists? Okay. All right, try number 4 then.
What's B?
All right, so I'm just going to call this even 2 out of 6. So the denominator is the total what? Let's describe it.
Total possibilities of written roll a 6-sided dice 6 times.
Okay. Split into even odd, right? That's an important descriptor, I guess. So that word even means that this is split into even and odd outcomes. That's really all we care about. So it's not worrying about the fact that there are 6 numbers on there. It's just how many of them are even, how many of them are odd, is really what this is coming down to. So do you see how this is the same as the coin flip? When you look at it from the perspective of even odd. So how many ways can I roll dice and get either even or odd? 6 times. 2 to the 6th. Why the 2?
Because it's 50-50.
Yeah, there's 2 different outcomes, odd or even, and we're doing that 6 times. We're not choosing, right? There's no, for the denominator, there's no choice. It's just roll, 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 etc. Okay, how about the numerator?
6C2.
Order doesn't matter, so we have 6 numbers and we're picking 2 of them. Okay? So what is 6C2? Actually, before you tell me, let's write this. So total ways to roll even, odd, or odd 6 times. Okay, and then this is number of ways to pick 2 of 6 numbers. Anyway, what's 6C2?
20. Oh, wait. 15.
Good. And then 2 to the 6 is 60. Okay.
That's
And then-
23.4%.
Can we, what?
That's 23.4%.
Okay,
Not necessarily.
23.4%. We can't reduce that.
So,
How'd you do?
I actually got it right. So.
Way to go.
Okay.
Awesome.
I screwed up. I overcomplicated it.
Well, I understand. I think that is easy to do with these. How about number 5? This one is even different, even more different. So let's read it. Test consists of 9 true-false questions. So as soon as you hear true-false, what are you thinking? 50-50, good. So a student who forgot to study guesses randomly on every question. What is, by the way, that's a really dumb strategy, but you'll see his percentage is not very good, I think.
Oh, you'll see that he has like still a good chance-ish that he gets them all right. You know, it's like.
If he's guessing
I
randomly.
mean, technically it gets worse.
Anyway, what is the probability that the student answers something different this time? 2 questions correctly. What does it say before the 2? At least, which means what options would satisfy this question?
He gets them all right.
3, 4,
Yeah.
5, 6, 7.
2, 3, 4, 5, 6, 7, 8, or 9. All of them, right? Everybody follow?
Yeah.
Okay. How does that change things?
We can't use the 2 or it'll be.
What if he just got 2 right? Like, what if the question said, what is the probability that he answers just 2 questions correctly?
Then we could do 9C2.
Yep. Okay, so here's what he just said. Well, what's our denominator, first of all?
2.
Okay. So we have a 50-50 chance, true, false, done 9 times. So we have 2 to the 9th denominator. If it didn't say at least, then we would have,
9C.
9, that's 10. 9C2. How many ways, like out of the 9 questions, how many different ways can he get 2 out of the 9 correct? Okay, so that's the 2. But 3 works, 4 works, 5 works, etc. So how do we account for all of those options?
We do 7 continuous. Or something.
7 continuous?
Or like the exclamation point. You
Oh, I
subtract
see
that
what
from
you're
the 9.
Oh,
And then that gives you like
factorial.
a minimum of 2 like incorrect, and then you get all the ones correct. I don't know if I'm making
Good thought.
sense, but
Good thought, but remember factorial is a multiplication thing. And this is OR. It's like an OR probability embedded in there. 2 or 3 or 4 or 5, right? Okay? Are those mutually exclusive? Yes, technically like 2 is mutually exclusive from getting 3, right? They're not the same thing. So what do we do when we have OR probability? OR and mutually exclusive. What do we do?
Add them up.
That's adding, right? So what would the next one say?
Same.
Same denominator. Now let's just focus on it. Now we're trying to get 3 correct.
yeah,
9C3.
9C3. Why don't you go ahead and finish that off? Alright, so I wrote it all out. 2 to the 9th. We had 2 to the 10th, so it's half of that. So 5, 12. Okay? 9C2 is what?
36.
Okay, so 36. And then 9C7 is also 36. Remember how we saw that those are the same? So I'll put that down here. Okay, and then 9C3 is what?
84.
And 9C6 is also 84. So any of the ones that add up to the total aren't the same. So 4 and 5, those will both be the same. How much is that one?
126.
And then where are we now? 9C8. How about that one? 9 and then 1. Anyway, add all that up. And they all have the same denominator. So what's that total? Okay. So it's almost 100% probability, right? Everybody good on that? When we say at least 2. If we just said 2, then it would be 36 out of 512, which isn't very good. But anyway, and then I don't know if you heard Gabe, but he suggested this. Instead of doing all the ones he could get right, what if we just take 1, so 100% probability, and subtract the ones that he can't, like the ones that didn't qualify in our question. So if we subtracted 9 and get 0 correct, and 9 and get 1 correct. So 9 choose 0 is how many options? 1. 9 choose 1 is 9. So that's 10. Right? So if you look here, 512 out of 512 would be 1. If we subtract 10, then we get the same. So that's a little shorter. Either way. And again, we'll have the binomial probability theorem equation. It looks a little ugly, but it's not too bad. All right, let's do one more. Let's do number 7. So, launching firework. Let's, again, just to reiterate strategy, let's say this is just some random test problem. So, we got to think through or, and, conditional, independent, mutually exclusive, all that stuff. What's going to tell you that this is combinatorics?
Random and probability.
I wouldn't say that the random shows up in quite a few. Not that one either. Good thought though. Because remember random, like I could say pick 4 cards at random, but that doesn't necessarily mean it's this.
Yeah.
Okay. It's actually this right here. How does that tell you that it's combinatorics?
Oh, because it's
Are we doing just a whole bunch of trials? No. It's just picking some of something, right? So this tells us the word like pick. She picks 6 of them, so we know that we have to account for the fact that it could be these 6, or any other combination of 6. Okay? So, and then what is the probability tells us that we're not just counting, but we're actually needing the fraction, right? So probability that we have 4 blue of 6. Okay? So this again, and you notice on all of these we have talked about the description of each of the numerator and denominator. And I think that helps narrow it down to what you're trying to find. So what is this? Total ways to what? Let's describe it. Total ways to pick 6 of 14. Okay? So what is that?
14C6.
Good.
And then on the top, would we do like 5C4?
Well, before we do that, let's describe it.
For
Number of ways to
have 4, like 4 to not.
okay. So 4 that are and okay. So number of ways to pick 4 of 9 blue and 2 of 5 red. Everybody good on those? Okay. What did we say yesterday when you do an and? Crud, I forgot to do the example in your notes. Huh? Yeah. So 9 choose 4 times 5 choose 2, and then plug all that stuff in your calculator.
I got 180 over 3.
What was it?
I got 180 over 3,003.
180 over 3003.
Yeah.
How'd you get 180?
Because I screwed up with the numbers.
So you told me a wrong number?
Well, I told you what I got for mine from escrow to like, make sure
Do we
that-
agree on the 3,003 at least?
Yeah.
Alright, somebody do 9C4. We actually saw that a second. It was 126.
126, yeah.
And then 5C2 is kind of
That's 1,160.
1,000 what?
260.
Hooray.
See, I can fix my screw ups too.
Good. Okay. I will post all of these as examples on Google Classroom, but I do still want to come in and write notes on them. It would be good to have a few more people here, but maybe we'll just pick one of these last few to write down as an example on Monday. With that though, we're we're over the peak of this unit, I'll be honest. I think you're gonna feel like it's easier after this. We have 2 more things to talk about. And so that's gonna put us to testing probably Thursday next week. Okay? Think like Monday, Tuesday, the next 2 topics, Wednesday review.
Which one? I'll be able to get that.